Alright, so let's dust off our brains because I know how much we all remember statistics, but it really isn't that big of a deal. Alright, so is y equals 2.6x plus 2.6 a good fit for the data shown in the table? To figure it out, finish the data, or excuse me, not finish the data. Data's already been finished. Finish the table and create a residual plot. Alright, so first things first. So I need to find the predicted value. So y is equal to 2.6x plus 2.6. All right, so 2.6 times 0 is 0. So then the predicted value would be 2.6. All right, so now 2.6 times 1 is 2.6. 2.6 plus 2.6 is 5.2. So then I've got 2.6 times 2, which is 5.2. And then you add 2.6 to get 7.8. And last but not least, 2.6 times 3 is 7.8.
The time is almost 3 p.m. All students remaining on campus at this time.
And then you add 2.6, and you've got 10.4.
Thank you.
All right, so now 4 minus 2.6 gives me 1.4. 3 minus 5.2 gives me negative 2.2. 8 minus 7.8 is 0.2. And 11 minus 10.4 gives me 0.6. So I'm going to go over to my residual plot, and I'm going to plot. So when I look at 0, so 0 has a residual of 1.4, so it's going to go right about there. 1 has a residual of negative 2.2, so we're down here. 2 has a residual of 0.2. And 3 has a residual of 0.6, so I'm right above. So there's my residual plot. So, is it a good fit for the data? I would say yes, because you have at least half the points that are near your x-axis on your residual. So, but ideally you would like them all clustered around your x-axis. Alright, so now we're looking at correlation coefficients. So the correlation coefficient is related to how does your line of fit relate to your data. So I want to match. Alright, so let's look at this part A. So I got the scatter plot. All those points are everywhere, so there is no correlation in this data. So you would put 0, because there's no correlation coefficient, no correlation. So B, if you notice, if you were to draw a line, your line is going straight up, and it's a positive. And this is almost making a perfect line, but not perfectly. So we're going to say that this correlation is 0.9. Or excuse me, not 0.9. This one is 0.3. This one is negative 0.9 because it's almost a line, so it's almost perfect. This one is positive 0.9, and this is negative 0.3. So basically, you always want, so this would, since this is closest to 1 because it almost makes a straight line, this is closest to 1 because it almost makes a straight line. So you always want your correlation coefficient close to negative 1 or positive 1. You don't want it close to 0 because then you end up with this hot mess.